looking at the sine and cosine ratio. These are going to be the other named ratios that we're going to use. So we're going to give these specific ratios some names. So we've given the tan ratio, the opposite to adjacent ratio, we're going to now call tan. We're going to use now the opposite to hypotenuse ratio. So when we look at this angle here, the opposite side or the vertical side compared to the hypotenuse is going to be, we're going to now call that the sine ratio. And our calculator knows that as a sine ratio. And the third ratio is going to be when we have the adjacent to hypotenuse side. So the horizontal side here, the adjacent side, when we compare that to the hypotenuse, that's going to be the cosine ratio. We're going to call that the cosine ratio. And please make note that the sine ratio, that opposite side, can never be longer than the hypotenuse. So the value of the sine ratio can never be greater than 1. And same with the adjacent side compared to the hypotenuse. The adjacent side can never be longer than the hypotenuse because the hypotenuse is always the longest side. So these two ratios will never be bigger than 1. So if we get sine ratios that are bigger than 1, we've done something wrong. So some people like to remember these ratios with this acronym SOHCAHTOA. And the acronym stands for SO is sine is opposite in hypotenuse. Ka is cosine adjacent to hypotenuse. And TOA is tan is opposite to adjacent ratio, okay, or the slope ratio. So this is a very useful thing that can be used. This is fairly universal as well. So when we say SOHCAHTOA, most people understand what we're talking about. So given these triangles, we're going to work out these specifically named ratios and relative to the angles that they are being referenced to. So in this case, sine of angle A. Sine of angle A is going to be the opposite side. So first of all, we have to locate angle A, and sine is going to be the opposite and hypotenuse ratio. So I find angle A, and I locate the opposite side. So opposite side is length 9, and I'm going to compare that to the hypotenuse side, which is square root 97. Okay, and that as a fraction looks like this. Sometimes when we use our calculators, we're going to end up with decimals, so we should be aware of the decimal values, that these can look like a decimal value as well. So I'm going to round this to 0.914. So the cosine ratio is for angle A, so we look at cosine is adjacent, the adjacent to the hypotenuse. So we find angle A, the adjacent is the side next to angle A, and the hypotenuse is always the hypotenuse. So we're going to compare the adjacent side to the hypotenuse. So there's my exact value of the cosine ratio. And again, we want to get used to using these values, but they do show up as decimals as well. So the decimal value for this is going to be 0.406. Okay, so I'm going to round that to the third decimal. And then the tan ratio is going to be the slope relative to angle A. So it's going to be opposite to adjacent. So it's going to be 9 to 4. And this works out to be 2.25 exactly. But I'm going to put an extra 0 on there just so that to be consistent with the 3 decimals. So sine of angle B then is we're going to do the same thing, but now everything's referenced to angle B. So sine is going to be the opposite of angle B, which is 4, compared to the hypotenuse, which is root 97. And it's important to note that the cosine and sine are just opposites. Okay, so if we take the complementary angle B, the cosine of A and the sine of B are the same. In fact, cosine actually means the sine of the complementary angle. So cosine A means it's the sine of the complementary angle B. So cosine B, then, we're going to look at adjacent side, or 9, compared to root 97. And that works out to be the sine of A. Okay, and the tan of B is just going to be the reciprocal. So instead of 9, the opposite 9 to 4, the opposite of B is 4. Adjacent is 9, so we end up with 4 over 9, and that works out to 4 repeating. Okay, so there is how we use the sine. We've used these ratios before, but now we're going to give them specific names. So this opposite to hypotenuse ratio is now going to be our sine ratio. So opposite B to hypotenuse of B is our sine ratio for B. And adjacent to B, compared to the hypotenuse of B, is going to be the cosine ratio for B.